Aloha and welcome to this module on integrated development environments. Oftentimes I'll say interactive development environments, and other times I'll say IDE. All means the same thing. It's one of the most important things, probably the central tool that you'll learn to use or need to use this semester and for software engineering in general. So for that reason, I would say that this module might possibly be the most important module of the entire course, and I'm glad that we're getting it out of the way early because really you want to do the important ones first. So what is an IDE? Well, it's basically a software development tool that understands the language that you're working with. Okay, that's the key thing. If it understands about the programming language that you're using, it can provide a whole bunch of value-added services, such as an editor that understands if something's syntactically correct or not, can balance parentheses and braces, it can do compilation for you, it can provide a debugger, and so forth. Okay, there's also some more, other features you can have if you want to define a new package or some new user interface feature. It could build in some little wizard to take you through the steps necessary to do it. It can support, if you're using GitHub or Google Project Hosting or Subversion or whatever, it can provide interface to that so you don't have to go out to your external environment. And one of the most important things it can do, really I use this, probably almost every day, is the refactoring tool, which enables you to easily rename different compilation units. That is extraordinarily useful because as a program evolves, your conception of what the different fundamental building blocks of the program evolves at the same time. And if you can rename things as you discover that their functionality has changed and they really represent something slightly different, if you can keep those names changing to actually reflect the current context, it's a huge win for readability. So integrated development environments, IDEs, they're awesome. Okay, so what's not awesome? Not awesome means Notepad or TextPad or some kind of primitive editing program. VI, I think not awesome, but other people think awesome, so that's kind of in the middle ground. On the awesome side, Emacs, Eclipse, IDEA, Visual Studio, NetBeans, Xcode, and so forth. They're all IDEs. Okay, so if you can, one might say, why use an IDE? Because they're so complicated, and you come up with this screen, and there's so many crazy little palettes and tools and icons, and what does it all mean? And maybe you're going to wait 5 seconds to bring it up. Whereas if you can bring up Notepad in an instant, and you're familiar with Notepad, and you feel like I can get my things done quicker in Notepad, those are bad reasons. Okay, the fact that it comes up faster, basically if you've got a modern environment, you bring up your IDE and you just leave it up all the time. It should just be sitting there in the background, and then there's no time to bring them up. Secondly, oftentimes if an IDE comes up slow, it's because you haven't configured your environment correctly. You should be turning off, your crazy virus protector that's going to scan all of the jar files or all the, the binaries associated with that IDE directory, when it starts up, so you're not wasting all that time waiting for it to scan some kind of binary file that's already been assessed to be free of viruses. Okay, but the most important reason why you want to use it, despite this learning curve issue, is because once you've gotten over the learning curve, you're going to be faster. You're going to be able to implement things that work correctly in half the time that you could before you started using IDEs. And also, there will be certain things that you might never be able to implement using a plain old text editor like Notepad. Okay, because the problem is too complicated for you to understand how to get it correct without the supporting infrastructure that an IDE provides. So think of that. Learning to use an IDE, getting fluent in it so you can work fast in it, means you might be able to solve problems you couldn't solve before. That's super cool. Okay, and there is the pragmatic reason that in fact some people during their interviews are going to ask you what IDE you use or even watch you code, and if you fire up Notepad in an interview, for some people that's it, interview's over right there. Okay, so certain things are easy to use, but they don't scale well. Other things are harder to use, but enable you to do things you weren't able to do before. That's what an IDE is going to do. If you look at compilation as a simple example, if you're doing something, a non-IDE, you're going to be switching back and forth between different environments quite a bit, and it's going to slow you down. Whereas within a particular IDE, the whole experience is much more seamless, and certain kinds of things you aren't even thinking about just occurring for you naturally. So it's a much more aesthetically pleasing experience of programming when you're using a good IDE. Okay, so what do we have in an IDE? We're going to have support for coding, we're going to have code completion, background compilation, we're going to have support for testing, we're going to have support for debugging. Okay, and then finally this very important refactoring capability, which is going to enable you to easily change the shape of your program over time as it grows and evolves to take on new functionality. Okay, so here's some screenshots of Eclipse showing some of these features. Here we have this server properties, which is not defined in the current file, and you can see to the left there's this little light bulb thingy with an X next to it. What that means is that Eclipse actually has an idea for how you could make this line of code syntactically correct. In this case, it's by including an import statement which will define that particular class for you. So one of the things, they talk about Java being so verbose, and that's why we should be using Scala or Python or whatever. And one of the responses to that, not to say that, in some sense I do actually agree with them, but some of the verbosity of Java can be overcome by the use of a good IDE, which can help you write all your... I haven't typed out an import statement in I don't know how long. I just type the file name, and then I use Eclipse to complete and insert the correct import statement for me. Here's another thing. Running an application or running a unit test directly from within the IDE can make it much faster to do development, and in fact enable a whole style of development called test-driven design, where you write the test case first before you've even written the code to implement it, and then you write the code to implement it, running the test repeatedly. And in order to make test-driven design and a test-centric approach to development work correctly, you need to have a fast and easy way to run the tests. IDEs help you to do that. Here's another great feature of IDEs, which is the ability to incrementally step through each line of code in the program, inspecting the values of defined variables and data structures at each point. Okay, so if you don't quite understand what a piece of code is doing, this can be a really effective way, much better than kind of inserting print lines at every point, after every single statement. In this case, what you can see is we're at one line of code, and we can see all of the declared values, and even drill down if we have some collection, like in a list of elements, we can drill down and see all of the elements in it. And that would be very painful to do with print statements. Finally, refactoring, one of my favorite features is the ability to say, hey, get file name, I want to rename this method to a different value. And the thing about Eclipse or an IDE is that it's smart. If you say get file name in some comment somewhere, it will know that that's not a method name. In fact, if you had a variable named get file name, which would be bad because that'd be a bad name for a variable, but let's just say you did. Eclipse is smart enough to know that when you refactor and rename this particular method, it's only going to rename those strings within all the files associated with your system that are actually method invocations, and local variable declarations or other kind of objects could be named the exact same thing, not a problem. Okay, so here's some things that, if the IDE, if you're provided support within your environment to do them, you're going to actually do them. One is finding all of the instances of a particular string within your system because you're trying to understand the context for its use. To single step through a function using the debugger, as we just saw. To generate a UML diagram that represents the larger scale structure of your system. Okay, to figure out, I've got some method name, I'm not quite sure what it's called, but I know it starts with getFoo, and then I can see all of the other methods that actually have that as its prefix, and then find the one that I want. Okay, reformat code. So I'm importing some code. Someone else wrote it. There's some tabs in there. There's, the indentation is four spaces rather than 2 spaces. I can go through this 1,000-line file and reformat it in an instance. Checking to see where the matching braces are, so I make sure that some expression that I have is correct. And as we saw, I just recently changed a method name. So these are all things that are trivial to do if you're working within a language-aware interactive or integrated development environment. Very time-consuming and painful to accomplish if you're not. Okay, so there are build tools. What's the difference? IDE support are focused on the process of writing code and getting it correct. Different developers might have different preferences for their IDE. So in the same project, you might have some people using Emacs, some people using IDEs, some people using Eclipse. A good software development environment should allow the possibility for developers to be using different IDEs. On the other hand, build tools provide support for IDE-independent, cross-platform, and usually automated compilation, testing, and packaging. Okay, so there you typically don't have multiple build tools for a project. You standardize on one for a given project. All of the developers are going to use the same build tool, and a build tool will provide automation so you can actually have builds built for you every time you commit code. Okay, IDEs don't really generally have that kind of automation. They're intended for human, kind of human interactive usage. So for this class, we're going to use Eclipse. The reason why we're going to use it is it's pretty good. Maybe not the best, but pretty good. It's open source and free. Okay, that's good. It's very, very popular. So many of the environments that you go into after this class will use Eclipse, and so you'll be familiar with it. It runs on all platforms. There's no issue like that. There's a lot of infrastructure for integration with other kinds of tools, and I want everybody in the class to use Eclipse because then it's going to help you share information with each other, work with each other. If you look over someone's shoulder and they're programming in Eclipse, you're going to know what everything looks like from the get-go. It's not going to be, if one person is using IDEA and the other person is using Eclipse and the third person is using Emacs, then when you look at someone else's over someone's shoulder to help them with their code, you're going to be distracted by the IDE and wondering how the IDE works as opposed to focusing on the code. So we're going to make everybody use Eclipse so that you don't have that problem when you're trying to help each other. All right, thanks a lot. See you soon.